Hello, IBSL2. This topic is on domain and range, and in particular, domain and range in the functions logarithmic, exponential, rational, and square root. And first, I want to just start off with a review of domain and range, and remembering that functions are mappings. Values go into the function, and values come out of the function. So the entire set of numbers that can be entered are called the domain. So that is the input. And the entire set of numbers that output from the function is called the range. Okay. So the input is the domain and the output is the range. And often when we're graphing, it's easier to assume that the domain is x and the range is y. So if we look at a problem with an algebra function where our f maps to 2x squared minus 3, so our y is equal to 2x squared minus 3, where x is any element that is a real number. As we're plugging in values for our input, all the x real numbers, as we plug in different values and get our output, we can see that our range will end up being restricted. Since our x is squared, the smallest range that we'll get, the smallest y value that we'll get is -3. So the domain can be any value in this function, but our range is going to have to be a value greater than or equal to -3. Within the IB questions you'll see on the exam, they'll have questions about domain and range. And some of them that we've seen are, is to write down the range of the function, write down the domain of the f of x. Also, I've seen it written as what values of x for which f of x is undefined. And in addition, they've asked you to write down equations of the asymptotes of the function. And so, particularly in this video, I want to talk about the functions that have restricted or non-continuous domain and range. And we've reviewed those a lot in Algebra 2 and wanted to bring those back. So logarithmic, exponential, rational, and square root. So a couple things to remember about logarithmic is the base of a log must always be positive. So the base, remember what the base of a log is. So if you have it written in the log form, where you have log, this is the base e of x. And remember, e is the number 2.71828. And that you would need to remember for the paper 1. The paper 2, obviously you'll have the calculator and you can use that to help you. But the paper 1, remember what e is. And then log base e of x, remember we call that our natural log. And so it's also could be written as ln of x, or the natural log of x. If we're going to be graphing our log functions, they have vertical asymptotes. And in particular this, the ln of x, or natural log of x, it has a vertical asymptote of x equals 0. And you'll see a natural log function. A lot of times we see that in nature, trees, they grow in a natural log. They can be described as growing in a natural log function. Other items that you'll see as well will have this type of growth. And so if you think about just how a tree grows, in particular it grows quickly right away, but then slowly grows over years, to help you remember what that function looks like. And it will always have a positive base. So if this question was to ask us, the first question here, where write down the range of f of x, what would that be for this log function? So in our log function here, our range is not restricted. It could be negative infinity all the way to positive infinity. Now if they asked us our domain of this function, then that would be restricted. Our domain of f of x would be from 0 to positive infinity. So if that was the question, our domain would be restricted. And remember, it will be parentheses here that will not touch our vertical asymptote. The function's undefined there. So it'll be from 0 to infinity. All right, let's take a look at our exponential function. And remember, our exponential, we have exponential growth, or we could see exponential decay. An example of an exponential growth is 2 to the x power. And an example of exponential decay, it could be written as 2 to the negative x, which is also 1/2 to the x power. So that would be an example of decay. And we talk a lot about exponential growth with money. We hope our money is always growing exponentially. We also talk about exponential growth with bacterial, that bacterial grows exponentially. And with decay, probably a recent thing that you're thinking about or hoping to purchase would be a car. And one decay or depreciation value of our brand new cars, they actually depreciate in an exponential decay function. When we're graphing our exponential functions, you can easily use a table to help you if it's on the paper one, and then remember you can always convert the log to exponential to help you if you need to. If it's on the paper 2 and you can use your calculator, remember you just put this into the y equals 2 to the x power, or whatever the function is they're asking you to graph. With our exponential functions, they will have a horizontal asymptote. And in this one in particular, our horizontal asymptote is y equals 0. So both our exponential growth or exponential decay will have a horizontal asymptote. All right, so if they were going to ask us for this question, write down the domain or the range of this function for exponential, our range would be 0 to infinity, and our domain would be negative infinity to infinity. Okay, if they ask us for our asymptote, we would say y equals 0. For our rational function, remember rational functions, they would have a value in the denominator that would cause it to be undefined. And in particular, this is our parent graph of our rational function. They have also horizontal and vertical asymptotes, and these can always be created with a table for the paper 1 exam. And for paper 2, if you're going to be putting this in the calculator, and I'm going to show you, we're going to be using parentheses. I'll show you a problem at the end of this video. But remember, with a rational function, you could have them in 2 different quadrants. And here, this 1 over x, we have a vertical asymptote of x equals 0 and a horizontal asymptote of y equals 0. You can see them in the opposite quadrants, where 2 and 4, or it could be in quadrants 1 and 3. In addition, some of our rational functions We could have in quadrant 1 or 2 or 3 and 4. So just remember how you graph these using the calculator or a table. Just plugging in your x values for your input and your range for your output. Remember also they could have holes. So if we had a function where the graph is y equals x minus 3 and x plus 2 over x plus 2 and x minus 5. Remember this would be, the asymptote would be at x equals 5. But here, where the this, if you simplify, this would be gone. It would equal 1, but it is still part of this function, so there would be a hole at the negative 2. So the function would be undefined at negative 2, and you would have a hole in the graph, or a discontinuous point in the graph. So that's another thing to remember about rational functions. There can be asymptotes, and there also can be just discontinuous points in the graph. And we'll look at that again at the end of the video. The last function I want you to think about is the square root function. And this function, a lot of times, it comes up the question, and you can just graph it again using your table input, input values, and for your x to get your y values. And the question that typically comes up with our square root are write down the values of x for which the f of x is undefined. So if you think about this square root function in particular, what values of x for which the f of x is undefined? So it would be all the values left of this endpoint, and we could represent that as all values of x that are less than 1. Okay, so a lot of the questions can be asked in different ways. So we could be asked to write the domain, and if you're asked the domain, you'd put 1 to infinity, or for the range would be 0 to infinity, or you could be asked what values of x for which the function is undefined, and that would be any value less than 1. So it couldn't be 0.9, couldn't be 0, couldn't be negative 1. It can't be any value less than 1. Okay, let's take a look at this one. I want you to go ahead and try it. Remember, when you're graphing your function and they give you the domain, you only graph that part of the graph. So the first part they want you to do is to graph the function. Then they want you to write down the vertical asymptote, and then they want you to write down the range. So go ahead and try that and bring it back. Okay, so this would have to be on the paper 2 exam where you have your calculator. This is not a known function for us. So we have a square root and a rational function. So you would want to be able to use your calculator for this, and you put 3 divided by, and then depending on your calculator, you would need the entire parentheses and the square root as well in a parentheses, because you want the whole item dividing 3 divided by the whole thing. So once you have that in the calculator correctly, then you would hit graph, and you can see our function is kind of strange. But this is what you'll be graphing on here. Remember to use your table to help you. So you hit second table, and they want from -3 to 3. So we want to, at -3, that looks like there's an asymptote, the function is undefined, which makes sense because that would go to 0. And then also at 3. So these points you would graph on your grid. Go ahead and make sure you can do that, and then bring it back to check. Okay, so you can see in the mark scheme that 1 point would be for the general shape and 1 point for the y-intercept. And then as the asymptotes, as we talked about, x equals -3 and x equals 3. And then our range would be y is greater than or equal to 1. All of the values would have to be greater than 1.